Introducing Unit 3, Electric, Gravitational, and Magnetic Fields. We investigated gravitational field and learned its effect on gravitational potential energy in general. We investigated electric fields and saw the relationship between like and unlike charges. We investigated magnetic fields and saw how they can interact with electric fields to form electromagnetism. It goes without saying that this unit has much of an impact in our world. And now I'm going to share some other applications with you. When I throw a ball into the air, it comes back down. When I jump, I find myself contacting the ground soon after. When Newton sat under a tree, an apple attacked him. These are simply just demonstrating the result of gravity's existence, which we knew from before. Now, where we didn't further study was gravitational fields, a vector field. Ultimately, the reason why all the actions above led to an attraction towards the center of the Earth is because the gravitational field of the Earth at any point is defined as a gravitational force felt by the object at that spot. Therefore, us humans are bound to Earth because the gravitational field produced by the Earth is far too much to naturally overcome. Essentially, everything around us, including ourselves, are visuals of the application of gravitational fields. Even the satellites in space are affected by Earth's gravitational field as long as they are orbiting. You might be asking, however, how are rockets or rovers launched and how do they leave Earth's gravitational field? Well, that's where the application of our knowledge about gravitational fields has been utilized. For an astronaut or robot to land on the moon or on another planet, they would have to completely escape Earth's gravitational field, meaning they would have to attain escape velocity. Achieving escape velocity is one of the biggest challenges facing space travel. The rocket itself requires an enormous amount of fuel to break through Earth's gravitational pull. All that fuel consequently adds significant weight to the spacecraft, and when an object is heavier, it takes more thrust to lift it. But to create more thrust, you need more fuel. This cycle is what needs to be resolved, and scientists are hoping to create lighter space vehicles, more efficient fuels, and new methods of propulsion that don't require the same ingredients to attain great speeds. These modifications will forever change space travel and will definitely lead to new discoveries about the vast universe we know very minimal about. Possibly tours to Mars, round-trip journeys to the moon, and even more that we continue to dream about. From what we've learned, electric fields are created by the presence of electric charges. We also learned Coulomb's law, which states that the magnitude of the electrostatic force of either attraction or repulsion between two-point charges is directly proportional to the product of their charges and indirectly proportional to the square of their distances. Simply this equation. Interestingly enough, an electrostatic process known as xerography abides by Coulomb's law, and it's what makes printers do what they do. In the first stage of this process, the conducting aluminum drum of the printer is grounded so that a negative charge is induced under the thin layer of uniformly positively charged selenium. In the second stage, the surface of the drum is exposed to the image of whatever is to be printed. Where the image is light, the selenium becomes conducting and the positive charge is neutralized. In the dark areas, the positive charge remains and so the image transfers to the drum. The third stage takes toner and sprays it with a negative charge so that it will be attracted to the positive regions of the drum. Next, a piece of paper is given a greater positive charge than that of the drum so that it will pull away the toner. Finally, the paper and electrostatically held toner are passed through heated pressure rollers, which melt and permanently adhere the toner within the fibers of the paper. It all happens oh so quickly, and we truly take this application of physics for granted. A magnetic field occurs whenever charges are set in motion. These moving charges create magnetic fields, and the interacting magnetic fields give rise to a magnetic force that's either attractive or repulsive. One place we see this concept in action is with the wonderful refrigerator. Have you wondered how the refrigerator door remains closed? Well, the weak ferromagnetic ceramics like barium ferrite or strontium ferrite present in the fridge magnet aligns the spins of unpaired electrons in metal atoms in the fridge in such a way that the magnet and the fridge door attract one another. This force is what keeps the doors closed and keeps the cold air within. The presence of such magnetic field has had the purpose of keeping foods fresh for longer and slow down the activity of bacteria, What's special about the last two mentioned fields, those being the electric and magnetic field, is that they are normally combined to produce electromagnetic fields, as theorized by James Clerk Maxwell. This intertwinement has been extremely significant in the development of many of our technologies we rely on nowadays. Essentially, electromagnetic fields are part of our daily lives, and they are present in such things as appliances, electronics, power lines, and electric wiring. Whenever there's a flow of electricity, both electric and magnetic fields are created, which leads to the production of electromagnetic waves. To learn more about some of the applications of EM waves in our lives, check out the next video in this series, which solely focuses on EM waves. Bye for now.